that's not just K2. So, you know, maybe that might be a message that we might share with elementary teachers. All right, so Elizabeth? Elizabeth was on the middle school, 6-8.
There was a lot of discussion of debate on the 7th grade specifically with keeping a lot of the earth and space and physical science. Then
Let me give you some history on that. In the up to the early 90s, the middle school had been 6th grade was physical science, 7th grade life science, and 8th grade was space science. And then there was a movement toward integrating them, not keeping them separate. And so in '09, maybe the 2 before then, that they had a integrated approach. It was not, you know, it was all sciences every year. And that actually is how many of the nations around the world who have great scores, if you want to look at scores, teach. So they don't just teach life science in grades, what is it, 1, 4, 7, like we used to. And so we went to this integrated approach, and you know, the teachers who had been teaching the single field science did not know the other sciences, didn't feel comfortable with them, and so there was a lot of unrest with that. And so in '09, we kind of trimmed that down a little bit, but we still kept that integrated approach in 6 through 8, well, I guess maybe K8. And so now,
so they did, in the process, pretty much nearly eliminate everything that had to do with earth and space, and if it was a tie into the life sciences, that's what was kept. For 6th grade, there wasn't a lot to be taken out because it is a STEM for 8th grade TEKS. But there was a lot of
it's still
debate
mostly
about
chemistry, physics, so.
But there was a lot of debate about the time to have to teach those TEKS in a certain amount of time, and if there was too many TEKS. So it was kind of hard to
For
find out.
6th grade?
For 6th grade. And then in 8th grade, the same issue was what was necessary for the foundation of getting ready for high school and college readiness. So we had a lot of discussion with the IPC and the physics and chemistry and biology departments. They came in and had a lot of discussions, and we just kind of looked at what was necessary for the benefit of what they needed to know in the high school. And they, with a lot of the changes, they were pretty much on board with what was changed, just to help not have so many TEKS responsible in 8th grade. So there was a little bit taken out. And we did, at first they went around and looked at how long it would take to learn a specific TEK, to see more or less what kind of calendar we had to work with. So that's pretty much what went on. But 6 still kind of, it still obviously ties with 8th grade. 7th grade is more focused with the biology. So
Specifically just taken out of 8th grade?
No, we're gonna get to that. I thought I would give you copies. I don't wanna get into the details on this. I do want you to look at it. Part of my testimony is going to be to request the board to look at what our national science education standards say about it, and the research, especially the cognitive appropriateness. I have said this before, calculating density is math. It is not science. And the chemistry teachers apparently came down and told 6th grade, we want you to keep calculating density because they need it in chemistry. And I'm thinking, okay, they don't need it in 6th grade, 7th grade, 8th grade, 9th grade, maybe 10th grade. That is 5 years later. They're not going to remember. And there's so many problems with the way science takes those formulas for density or even speed, and because we flip it around. They don't do that in math. We use decimal numbers. They don't do that in math. And so it's not a matter, I don't think, of solving it with a calculator. And there's nowhere in the national standards where that occurs. They need relative density, but they don't need calculated density until high school chemistry. And Paula used to teach high school chemistry, so we had that conversation. So hold on, I'm coming back to you. So the idea of looking at TEKS to see, is it cognitively appropriate? Do they need it? Is it in the national standards? In addition to what this committee's experience says. Now, the national standards have input from thousands of teachers across the nation about, I mean, that's how that came about, along with scientists and science educators, yes.
Two other things is there's no longer gonna be gridables for the science star, so they took that out, so they won't be.
TEA said there's no. TEA said that.
This was, what we discussed with the district, like the, science department. So they were showing us what kind of, the questions that were, not the questions that were gonna be asked, but the framework of what was gonna be.
Yeah, there's a new
tested.
framework, and in fact, I
But
was
there's no
gonna
gridables.
get to that in a moment. So that means TEA has said there's not gonna be any more gridables.
Yeah.
Okay.
And then another thing that we looked at was just a lot of the verbiage. It just needed to be,
Clean up.
yeah, cleaned up. And that I really like what we all came up with.
And the thing that came up this week, because Russell, we're gonna, be looking at that eighth grade TEK about, speed, velocity, and acceleration. My student teachers were in Laura's classroom last week, was it last? Yeah, last week. And that was part of what, Laura's, topic was on. And the kids have a lot of trouble with acceleration. And so I started looking at it, and guess what's in the national standards? No acceleration. What is in the standards that is not in the TEKS, there's two things that are not in the TEKS. One's molecules, that needs to be in there. And the other is momentum. And momentum is mass and velocity. That they can handle. But acceleration is very complex. You'll see that today. Agreed, eighth grade teachers? Oh, yes. Yeah, because Candace and I had a conversation about this same conversation last year. Looking at where are the kids having trouble. And along that same line, what is the lowest scoring area in math across the state? Measurement. We've been in classrooms where the teachers have said, the math teachers have said, oh, don't measure it. In one case, it was a fifth grade class, they said, count the cubes. And in fact, in the math worksheet from the book, from Fusion, right? No.
Go Math.
Yeah, Houghton Mifflin, right? Is it Houghton Mifflin?
Yeah.
Which science book has acceleration in the fifth grade, by the way.
It also has
What?
It also has
Photosynthesis. Anyway, so as long as students are not measuring with real objects, not paper, and not looking at a graphic, because a graphic is pictorial. If they don't have those concrete experiences with real measurement, with real materials, they're not going to understand measurement without it. We've seen that. That's what the lowest scores are in math across the state. So, TEKS, what else? They will have testimony on Tuesday. If you have any input about the TEKS that you see, the changes, you need to send it to the SBOE as soon as possible. And then if you have any, recommendations in general, and if I agree with them, I will also make the same recommendations about them. Well, I'm not going to say something. If I can't support it in the standards of the research, I'm not going to support it. Yes.
This being my first year teaching seventh grade math. My name is Dr.
Oh, you
Brian
are
Question.
teaching math.
I am teaching math.
Okay.
Area for the area and volume. It used to be, I'm sure, length times width times height. It was changed now to base times height times height. Is there like background on the why? Because I don't like it.
Where's Brian?
It's not,
Our star charts have
there's two meanings for the word base. Base with the lower case
Yes.
is a length.
Yes.
Base with the uppercase
Is area.
the area
base.
of the
Yes.
base, which works for every figure. When you said length times width times height, that is for a rectangular prism. That is not for every shape. So they're trying to make it more generic for every shape. Area of the base times the height is the volume a cylinder, of a triangular prism, of
Right.
those things.
Well, because then we fill, that area of the base in with the area formula, they're getting confused with, there's, yes, the base times the, and there's two heights now. There's two H's.
Where are there two H's?
Because, the second step, we tell them to fill in the formula, so if it's a rectangular
Wait a
prism.
minute, the second H is in a TEA document or
It's
in
a
a?
star chart, our star.
In the star chart, so it is a TEA document,
Yeah,
it's
so it's-
not made by somebody else other than TEA?
No, it's a star chart.
Okay.
Like you said, area of the base is a capital B, H, so when we fill in the area of the base for our rectangle, it will be BH, because that's what, like you said, it's the length times the
Or
width.
length times width,
But on our star chart, it has BH,
lowercase b.
lowercase BH, so now we have BH, parentheses, H, which should be the height of the prism or
Of the solid.
So they're getting confused because there's two H's, or most of our word problems on STAR, they use the words length and width. So then
The old ones do, you
Oh,
don't
yes.
have any new star items on the new teaks.
that's right, older ones. So when they see those words length and width, they get confused on where to put them in on the formula. Because there is no length and width anymore on the formulas.
On the chart, there's
Yes.
still always a length and width.
Right.
So, yeah, you're just gonna have to drill that into their head, not literally, but figuratively. You're just gonna have to do many, many problems with that and have them measure the length and the width, and then have them measure one that's called the lowercase base and the height, and see that, they're actually the same thing.
And how to actually label the objects. I mean, like Kleenex boxes or whatever that you're gonna use, they don't actually label that correctly according to the new standards.
Take some boxes in the cereal, have the kids bring in cereal boxes and have them label the edges that they're going to use for the length, width, and height, which is now solid base, height, and height. And repeatedly, and if they bring in their own cereal boxes, they can then take them home.
Yeah.
Yes.
I can even show you later how to teach that, the way that I teach it, that really worked well. Because I
Okay.
did 7th grade math for 8-9 years.
Sounds good, okay.
What I was thinking with the state board, we were supposed to be ready to go on at 1. We didn't go on, I didn't start because I was K2 until what, 5:30 or so? From that first thing in the morning all the way until they said we finally got to stop math is on the chopping block. They were actually at that point deciding whether or not to completely scrap it and start over. That actually came up. And the big debate is forcing students to master multiple strategies to solve a problem. And,
Nobody
No,
forces
it's
students.
teachers.
It's not the state,
No.
it's
Or-
teachers requiring students
Right.
to master multiple ways
Well,
of problem
see,
solving.
that was the impression, a lot of parents and teachers is the state's requiring us to do this.
That's not accurate.
So,
It is not true. It's
And
not.
it's huge.
It's commercial products that are
Mm-hmm.
incorrect, just like the one I said earlier about counting cubes instead of measuring centimeters in this case. And it's about misinformation, it's about teachers not knowing the TEKS, not understanding their national standards, not really understanding the TEKS that are based on the national standards. So teacher worksheets, commercial worksheets are the ones that are causing problems that the parents are bringing into the board to show them.
and I
So they
think a lot
should be
of,
exposed to those ways. And
Right.
they should pick a way that makes sense to them.
I think a lot of parents coming in, and they definitely have the board's ear, just kind of for all of us now, I'm a teacher now. Be careful, because a lot of the parents and the students are getting this anxiety that these different ways to solve a math problem, it's being used as a weapon, more like a tool.
I know, they
You
want-
will do this.
They want to take out all the process standards
Yeah.
in mathematics, which is absolutely asinine, if I can use that word. Because
Being
it is,
videotaped.
I don't care. It is asinine to remove the process standards for mathematics, because the process standards only say that the student will be able to justify, the students will be able to analyze, the students, your 3 questions, the I wonder, the how can I do that, that is the mathematics process standards, period. Yes, ma'am.
Well, there are TEKS though in 5th grade and.
Right.
that do say that they have to understand multiple strategies for division.
They have to be exposed to them, yes, and should be able to explain them, but mastery is a whole different
Right.
story.
So,
And requiring them to use a certain way to solve a problem and not have a choice of anything is not in the teach.
no, that's
Well,
not, but I
but the STAR
thought your
questioning,
comment
though,
was that
Doesn't it go to
the
like?
STAR
parents
question,
are
they
upset because we're teaching many different ways to go
And I think
about
some
solving a
teachers are,
problem.
well, and I tell them, because a past STAR question was a pictorial model or a number line solving for division with fractions.
So they had
And there's
to
a
know
number
how.
line, and they say which numerical expression matches the number line.
So that forces them to know
They,
that.
you're right, and, but what I tell my, and this may be wrong, correct me if I'm wrong, what I tell the students, because, based on what I've seen on past assessments, is when you get a word problem or you're told to solve, you do whatever helps you solve the problem, long as it comes from your head. You know,
And it's,
that's
Conceptually
great.
correct.
But you have to be familiar with these different strategies, so, because you will see this picture and then you will be
the purpose
questioned
of that
about
is
it.
to build number sense in the students' minds.
Right.
So that they can do things mentally if they need to. They don't have to rely on some algorithm that they have, oh my gosh, I've forgotten how to do long division, I can't solve any of these problems. They have other strategies in mind that they can use, and I just use long division because
Right.
it just popped into my mind. But there's a whole section in many of the textbooks now, especially the Vanderwall books, and many of you have the Vanderwall books, that talk
Who
about
doesn't have the Vanderbilt books and teaches math?
What does that look like?
You mean like one you've given us?
Yes.
I don't know.
It's got the white cover.
Anyway, it has a whole section on what they call invented strategies, and it's not really invented in the term of the kid figuring out something to do that nobody else has ever done. It's really in just alternate ways to think about it involving number sense, using the commutative, distributive, so it's all the properties that are there. They have this really strong sense of number rather than memorizing something. That's what it's about. We can work on invented strategies next month if you want to.
Yes.
And I have videos galore about it. But it's not, invented strategies is such a misnomer, I hate that. So it's using non-traditional strategies that make sense to the students. And that's what the different strategies are that are in the
Right.
TEAS. Non-traditional algorithms or strategies that should make sense to the students. For instance, when you see a rectangular array has 12 in it, and there's 3 rows and 4 columns, you should be able to know that it's a 3 by 4, 3 times 4 array. But you should also see groups of 4. You should also see groups of 3, depending on if you're looking at rows or columns. So that's just a number sense, like all the triangular numbers. When my first son was 3, I bought this book, How to Raise a Genius. And it worked. But a lot of it was math, and they would say, get some buttons out and make, triangular numbers out of them, make triangles out of the buttons. I used color cubes, color tiles, because I had them, and they fit nicely together. And by the time he was 4, he would say, cut my sandwich in a triangle, or cut my sandwich in a rectangle, or look, Mom, this number makes a triangle. He didn't call it a triangular number, but I can make a triangle out of 10 buttons. I mean, he would tell me that by the age of 4. So it's all about exposing them to these things, and that was a non-traditional thing. He can rattle off the triangular numbers right now up to a certain level, We've done triangular numbers in here many, many times. We've graphed them, we've done functions with them. I don't know if we've done it with this group, but I know Tim has been here a while, so you've done them. You may not remember. We've also done figurative numbers, rectangular numbers, triangular numbers, all of them. So it's just building a number sense. It's not forcing them to learn something that doesn't make sense to them.
There is some research that says that it's good to challenge kids to try to do something different in a way that's different than they always have, because that expands their thinking and makes their thinking more plastic, if you would, more
Yeah, it
flexible.
grows their synapses.
Yes?
I'm also the ESL teacher. So I guess, this conversation about having multiple methods. And you also use the word mastery though, so
I didn't use the word math.
well, in the conversation. You
Those
know,
parents are using the word mastery.
my ESL kids, who are beginner language speakers, also go to like a ESL second math class. Where they should be learning the background. So me and this, it seems that we're having, you know, I'm teaching it, I guess.
Could we come back to that and
Sure.
you have a conversation with Browning, because I know that's an issue we've seen around, and we'll come back to that after lunch, because that's a good topic.
Okay.
In fact, our student teachers, Paula and I are working on that ESL for
Yeah, 'cause we're
science.
having-
Yeah.
Sandra, can I just finish this real quick? Oh, this is this is a Vanderbilt book. There's lots of versions. This one is old.
That's actually Rochelle's.
That's
And it's-
5/8 though.
That's the 5/8.
That's
And
the 7
it starts early with invented strategies on page 44. And it says, you know, for adding two-digit numbers, there's lots of ways to do it. You don't have to add all the ones and carry, and then add all the tens. You can group them, which they're doing here, to numbers that make 10 first. I know y'all do that as adults. When you're adding a long string of numbers, you add the ones that add to 10 first. It makes it easier. So it's not something that's foreign to these kids. If the parents would actually read a book about
Just taught you that
mathematics,
section.
they would understand.
Well,
It's
I think
the teachers that have to
teachers
do this.
are
because-
isolating
Parents are the ones that are causing the issue. I've been well aware of this for over a
Yeah.
year. The
Yeah.
parents are causing the issue
Yeah, they definitely are, but they're taking teacher worksheets. That's their evidence.
without talking to the teacher.
Okay, observations, some of the things we're seeing in observations. We're seeing definite improvements for those who've been in their second year. That's why we asked for a 2-year commitment. So we're seeing definite improvement in instructional strategies. We're still seeing some lost instructional time in the classroom, and that goes back to too many teaks. Well, there's lost instructional time with pep rallies that a 5th grade teacher was telling us about. I said, pep rally? Yeah, we have cheerleaders and everything. Anyway, so, you know, we're seeing a district or school interference or stealing, if you would, of instructional time. But we're also seeing in classrooms, you know, the transitions take too long, the teacher's not ready to go, the lesson plans are not well developed, the questions are not in there, and that eats up instructional time. And the language is not explicit. So these are some patterns that we're seeing. We'll talk to you a little bit more about the observations. And then the last thing, I have been in conversations with Dahlstrom, because we have connections with Dahlstrom, and with Lockhart School District about developing a world-class STEM and preparation program. So we would have pilot schools that would be STEM schools in these 2 areas that we have connections with, if you would. And the idea is that we would have our block classes in there, so our students, our pre-service students would be in there, and our grad students would be in there. There would be collaboration of professional development between the staff, and, you know, we'd have these kind of conversations about, we get the real world, what's going on in the classroom, and then the classroom teachers, you know, it's our job to read the research and, you know, bring that in, you know, the professional standards, et cetera. And that we would place student teachers in there, that we would have teacher interns for a 4th year, so the master teachers would be in there like a lab school. And so we're in conversations, as I said, with Lockhart, because we have lots of connections with Lockhart, and with Dahlstrom, with Mr. Trevino and their teachers, 2 of them. So we'll be in some more conversations about that. If you think about what you think would have helped prepare you better to be a math or science teacher. So we're talking math, science, technology, computers, maybe art, et cetera. Okay? And that all of our candidates would go into those schools. They wouldn't be, right now they're just scattered out. No, elementary, K-12, K-12. Okay, so that's the overview for now. And so Russell, y'all know Russell, those of you who met him before. Russell, retired physics instructor here. We've done a mix year or so, I don't know what, just focusing on physics. And so what I asked Russell to do was to bring back an activity, well, a full morning of, maybe more, of graphing. Because graphing is not well understood, and of course, Dr. Browning is going to be bringing in the math when that occurs. And I was going to say something else. Anyway, Russell's retired now.
Yeah, which means my brain doesn't work much.
Well,
It's still on the lounge thing.
some of you know Russell, and if you don't, you have it today. We do have Gloria with us, so Gloria is new, and welcome Gloria. And Gloria is Brenda's partner at the new elementary school in Lockhart called Strong. Yeah, yeah, and I think everybody else is correct. Okay.
What do I do? Well, see, the quandary I've got is I don't know where you are right now. And so I've got two ideas. One is that little box right there where I took the previous ones we had done and shoved them all in there and got rid of the crap and tried to make it a quick, let's catch up. And then, of course, at 4:30 in the morning, I see things and I go, ooh, I gotta mark that, ooh, that's something. So we can go through that and then lead us hopefully into using the computer and a computerized system that can measure the properties that we're talking about. As opposed to just go right into it. See, there's an email that I got right. Theoretically, Russell will begin instruction with speed in 243 and know how to use that thing to make a graph. Well, are we even ready for that? Are we up to speed on speed? Everybody knows what I mean. So, what do you think? And that way, Dr. Browning gets to join in, because if there's a map, you can do it at whatever speed she wants to do it. Hmm? Yeah, there you go. That, I don't have to do it the whole time. Okay. There we go. Slideshow, come to the beginning. There we go. Can you see it? Just like you see the projector. What's that? Can you that? It's close to that. Can you guys see that well enough? Can the people over there do it? If they call this perspective. I guess we're stuck with it. That's the way it's going to be. That's it.
Oh, maybe Alexis, do you want that larger on the screen, you mean? What do you
Not
guys?
larger, but it'd be nice if it was rotated some.
Oh, no, we can't
I
rotate.
know, we can't help that. So this half the class just needs to move over here. Or, we'll see. Let me know if you can't see it and we'll go from there.
There is good, it's the same screen all the time.
Theoretically, it works.
Yeah, we just told them to suck it up.
Suck it up, buttercup.
Yeah, this is like real life.
This would help if I put the receiver in.
Yeah.
There we go. Okay, there's nothing there. Parenting 101. This is getting, for those that were not here and don't know about the little in section where we do a little graph and did some stuff, this is the essence of what we finally got to it, is definitions of words. Because in physics, we're really precise about what words we use so that we know exactly what we're talking about, and the difference between distance and displacement. That distance is the length of a path. Displacement is just from here to there. Or as I like to say, from this place to that place.
Can I make a comment? That's not the same in math, okay? So don't get confused, you math people.
And it's not the same, I guess, in chemistry or biology where they put water in the displacement and things like that. But if an apartment complex catches on fire, they tell you it displaced 15 families. Doesn't tell you how far they traveled. It just says they got out of this place and went to some other place. Got it? Okay, so we're going to be using distance mainly, but we'll talk about displacement when it needs to be. Okay, my goodness. Are you taking a good look at your surroundings? That's what it says to this. How do you take a good look at your surroundings? How do you even do it? Okay. Close your eyes. Everybody, close your eyes. Okay. What happened?
You move.
Are you sure? Sure, I am.
What is the evidence for your answer?
Exactly.
In relation to.
You went from
Relation
this,
to-
that place to that.
You're now in front of
You
something.
went from this place to that place.
So you're
From
sure,
my perspective, you are in front of another object. But I
So-
have marked you
you are referring to something and referring to my location relative to that.
relative to your hand.
You're sure the moon didn't move and I stayed stationary?
I'm pretty sure, yeah.
Sometime when we have time, I'll tell you when the whole building shifted down by 1 foot. Yeah, the whole building all at once, but we're wasting less time on it. So anyway, the thing is, to locate the position of something, we need a point of reference. Okay? And so, for instance, if I said front yard and backyard, what would be the point of reference for that?
The house.
Well, why is,
The house. Because there's in front of the house and behind the house. That work? You know, it's very much like a number line. There's a positive and then there's a zero. Thank you, stories. Yeah, I just don't even know what all that means up there. Ah, there's a good one. We're catching up. Point of reference, an indicator that orients you generally a game of horseshoes in the backyard. What is your point of reference? It's a tough one. That's one we play with a little bit. Penny James.
the pole?
See, when you play horseshoes, what do you say about the thing that you threw when it lands? You refer to the post? Is it not far enough or too far? Or off to the right or off to the left? Those kind of things? Hmm? Leaner. Yeah, that's it. Does that make sense? Then you pick some place, you're gonna say, that is the one we're gonna call stationary, and we're gonna close far from it, we're gonna do that kind of stuff. Okay, that's what okay. Whew. Penny slide game, that's what we did, I just had to do this so that we could get down to this. Whoop, back, there. Frame of reference, a framework that's used for observation and description. There are a lot of my students that confuse frame of reference with point of view. Meaning, I'm here looking at things out there, the frame of reference is the things out there I'm looking at. My point of view from over here, from my point of view. In physics, the frame of reference is all the other stuff around that we're gonna say, that's stationary. And then we're gonna compare the thing we're looking at to that. When you draw an X, Y, Z coordinate system, those don't keep moving on you. While you're doing your activity, they're not doing that, they're stationary, and then it moves within them. So it's just a way of labeling a stationary background, if you will. Does that make sense? When you play horseshoes, you had a frame of point of reference that was the stick, whatever they call that post, and a line from you to it. Because you was too far to the right, too far to the left. So there's frame, to make a frame of reference, you have a point, and then you have directions. So you can refer to those. Does that make some sense? Good, we're catching up. Okay, if I'm going too fast, you gotta stop and, you know, tell me slow down. If I'm going too slow, say speed up, I know this. Okay. I have no idea what this was. Do you guys want to talk to your partner? No? Okay. What it is, I really absolutely hate these kind of slides, even though they're in here, and I built them, I guess. This looks like math.
Yeah, it does.
Would you like me to zip through the whole point and the whole slide?
Well, let's see what it says first.
Here.
She'll be judging.
That's the stuff.
A potential zip. Oh,
I have no memory for what side.
so, all right. Do they have this?
No.
Okay, let's go forward,
Forward.
but not much, just a little bit.
That one?
Okay, so that yellow circle, which I couldn't see from back there, those are the natural numbers, which are sometimes called the counting numbers. I'm sure all of you are aware of those. 0 is not in there because you typically don't start counting with 0. And when somebody says, how many children do you have? You say, I have 3. You don't say, let me see, 0, 1, 2, 3. So then the next set, which is the purple, Those are the whole numbers, and they do include zero, the only difference, just a review. Okay, the next one. The integers, those are whole numbers that are positive or negative, but they're still whole numbers, no fractions or decimal fractions. And then there's the rational numbers, and that includes the common fractions and the decimal fractions, both positive and negative, and even repeating decimals are in there because they can be converted to a common fraction. And then the irrational numbers, the most famous one is Russell and pi, and square roots of numbers that are not perfect squares. So the square root of 4 is a rational number because it is 2, but the square root of 2 is irrational. So tell me a definition of irrational numbers. Let me pick on somebody. Kim. Are you science?
Yeah.
Okay, I won't pick on you.
We're not expected to know.
Tim? Well, you are, it's just been a long time.
She's trying to get me to talk. I can't talk.
I'm sorry, Tim.
Oh,
Pam.
I got it.
You got
It's
it?
An
Okay.
irrational number is a decimal number that does not terminate nor repeats.
Very well said. So what does terminate mean?
That they will
It
end in
ends,
zero.
stops, it ends in 0 if you're dividing something. And repeat,
This one, a number or a block of numbers repeats over and over.
right, such as,
The
the 45 there,
45.
45, 45, 45, 45 to infinity. Okay.
Would that also be
Those are
the
next.
set of all numbers that are not real
This is
numbers?
through eighth grade.
You could state it that way. Did y'all hear Russell's comment?
I'm sorry.
You could state that the irrational numbers is the set of all numbers that are not rational. In fact, the word here.
I know, that's what got me. I was
Not
figuring if I was an
rational.
English major, I could figure that one out.
Yeah. But math people sometimes don't look at words, do we?
No, no.
Not always, but go ahead. Wait, go back one more. So if you have all of the rational numbers and all of the irrational numbers, then those two together make the real number set. And the real numbers are all of the numbers that K through 8 deal with. Of course, when you get to high school, then you have imaginary numbers and complex numbers. So there are other numbers, but those are all the real numbers.
How many real children and how many imaginary children?
Many unknowns, so.
What is it? Oh, this is more math. But I can help you with the math and you can do it, and I'll just flip it.
Oh, there's more math?
Yeah, it's a real number line. And it's the number line that has
Yeah, here it is.
a reference point
That's okay, I don't need it.
and directions. And then one direction labeled positive is opposite.
Okay, so what numbers are up there?
Integers.
What steps they fall in?
Integers.
Integers, good, thank you.
Oh, well, I just pressed the button and nothing happened. Oh, wait. A reference place. Quadrants, I don't do quadrants. So do you?
Yes, we all do quadrants, that's a coordinate plane. It has 2 axes and they are perpendicular.
Cartesian.
It's a Cartesian plane named after Mr. Descartes, who did a lot of work with it. Funny story about how he did that, but we won't go into that right now. So quadrant 1 is the upper right, and then it goes counterclockwise. Quadrant 2, quadrant 3, quadrant 4. Can I ask them a question?
Sure.
So what are the signs, positive or negative, of the numbers that would be in quadrant 1?
Positive,
Let's
positive.
get these one at a time, Brandon?
Quadrant 1 is always positive.
Okay, so X is positive, Y is positive. So in quadrant 2, Rochelle?
X is negative, Y is positive.
Well said. X is negative and Y is positive. Quadrant 3, Randy, you answered one. Melissa?
X is negative, Y is negative.
Okay, quadrant 3, both of the numbers in the ordered pair are negative. X is negative, Y is negative, thank you. Quadrant 4. Elizabeth?
X is positive and Y is negative.
Good. X is positive and Y is negative, so what's your point of reference there? Did I do good? What's your point of reference for the positive, negative thing?
The origin.
The origin. Is that right?
Hmm?
Is that right?
Is that right? I don't know.
Yes. We'll say it's
You
right.
decide. I think for the entire coordinate plane, the point of reference is the 0.
Is the origin, yeah.
Yeah,
You did it
the
right.
origin. I would like to know about the positive x-axis. What quadrant is that in?
One is on.
Okay, please don't shout out, raise your hand.
Or call them a non-volunteer, the sticks are up there.
I'll try to answer his question. Please ask me how
I tried that my time.
Just the X.
His question is the x-axis, which quadrants or one or two or more is that in?
For Pamela,
Quadrant 1 and 4. It splits quadrant 1 and 4.
but is it in quadrant one?
No,
Is it in quadrant four?
no.
So which quadrant is it in?
It separates the quadrants. Distinguishes the columns.
What was the sign set for quadrant one?
Positive.
So is the y-axis at 0 is where it intersects the x-axis. So the x-axis has positive x's and 0. Is 0 positive?
No.
No,
Is it negative?
No.
So it's the x-axis over there in both quadrants?
no.
It's in neither quadrant?
Right. Because 0 is not negative or positive, therefore it can't be positive.
How wide is the x-axis? How thick is it?
It's an
That's what I'm getting to, because I'm the ornery little kid.
So let's move off of Pam and ask
What about-
someone else.
Okay, point 0.0000000000000000000. How many times do I have to go before I say 1 is in a certain quadrant? But the 0 isn't. When we go out to infinity and say finally, almost infinity, say 1, it's in a quadrant.
So Brenda had her hand up.
Go ahead.
Well,
So
isn't
we-
the x-axis make it out of points, and points have neither length, width, or height?
That's correct.
That's the definition of a point?
Well, the question is, which quadrant is it in?
Neither, because it's not, it doesn't have length, width, or height, so therefore, it's one of our undefined terms.
Yeah, it's one of those, I don't know how you
Depends on the
describe it,
thickness of your marker
edges.
when you draw it.
So Melissa, your hand was up.
I was gonna say, is it not just a frame of reference? Because you said our point of reference is the origin. And the frame of reference, it's a length, but it also has direction. So it's more of a way that we use to plot versus actually.
An actual real life thing, right? Like if you draw a triangle, right? Draw a triangle. It's the boundary of the triangle in the triangle.
It's like a philosophy class.
Yeah, there we go. So anyway, that's the kind of thinking that I like to do whenever I'm trying to get my language very carefully stuff.
So did we determine if the axes are in a quadrant or not? Did everybody in here get that straight in your heads before we move on?
What we could do is, Dr. Browning and I could be team captains, okay? So that whenever I shout out my opinion and shout out to her opinion, okay, you guys join us. I don't know how to phrase that.
I don't usually give my opinion.
Is it yes or no? Yeah. Do the axes have quadrants?
No. No.
Do anyone?
No.
You're supposed to say, hell no.
Oh,
But I
That's all I'm doing, all this discussion.
For me,
but-
We don't curse this school.
The only value for a physics person in a quadrant is that we can quickly label whether the numbers involved have pluses and minuses. That's all. I don't know about it in the math world if it makes a difference or not.
So we have agreed then that the axes are not included in the quadrants. They, as Pam said, they separate the quadrants, but they are not in
Right.
any of the quadrants. Either the x-axis or the y-axis, they are not in a quadrant.
Very much like the rational and irrational numbers, thinking of as a set. What about the boundary between the two?
Okay? So we've all agreed on that.
I hope so. If not, we'll just, but anyway, that's what they are. They're two number lines, the horizontal and vertical axis, and coordinates and quadrants. There we go. You want me to skip all this and just blast through it really quick, because we just did?
Yeah, we just did that. Okay, so pull one of the sticks out and ask somebody that first question.
He has no clue.
What are we doing?
Call them you.
Alyssa. Alyssa?
Not him.
Hmm?
Are you?
Okay. Are there any points that do not lie in any quadrant?
I would say yes, there are points that don't lie in a quadrant, the ones that fall on the axis. The Y or
ones
the
that-
x-axis.
Yeah, that are on the axes.
So she answered one and two.
Are we
I have no idea what this one
It's on the axis.
Not all of them.
What characteristics would points have that lie in a straight line, either vertical, horizontal, or diagonal? So what characteristics would those points have?
This one, like a vertical line. What's this,
What would those points have in common?
yeah, what kind of characteristics we're looking for? Sames or differences?
Yeah, commonalities.
Sure.
So Quentin's gonna do the pulling, huh?
Oh, okay, well, can you call out the names yet?
Oh,
Simplify it for us. It's not like I'm gonna edit one out.
it's on you, Melissa.
I was gonna say, I want to see this take it up with you. What characteristics would points have that lie in a straight line?
Just look at the vertical.
Mhm.
That either, for vertical line would mean that Y,
No coaching.
no, she's just coaching me on the vertical line. She knows I'm still that for a vertical line, Y is 0, no, yes,
What if it's
no,
not?
X is 0.
What
We're
if it's
talking about the
not?
axes, just any vertical line.
Any vertical line.
That it's vertical,
Yeah.
That's a good one. Uh-huh. What else?
that it's straight up and down.
Let me give you, okay, she's a science person, so let me give you an example. If I have the point, Kim, hush.
Is that ain't helping?
Yeah, and hush, Kim. And Pam, Kim and Pam? If I have the point 2, 3, X is 2, Y is 3, okay? Are you picturing that in your head?
Yes, it's
Okay?
right there.
What is the point, Pam? What is the point directly above that? Right, so we can start making a vertical line. What would be the coordinates, let me rephrase that. What would be the coordinates of the point directly above that if that were on a vertical line?
Above a 2, 3,
Yes, ma'am.
Are we using whole numbers?
Only whole numbers, thank you. Quentin.
that the Y would
Still
be
here,
one
Kim.
more.
The Y would be one more, so the
X
X here
would
would.
remain the same, and the Y would increase or decrease by 1.
Thank you.
That's what I meant. Unless there's a 1 and change.
So glad you were talking.
You know how many students I've had that whenever we go over their work and why it's wrong, they say, but that's what I meant. You go, but that's not what you wrote.
Yeah.
So anyway, let's go. Horizontal, do you
Can I
get
ask you a
points
question?
and
Do you have
diagonal?
any zip ties? Because I'm gonna tie Pam and Kim's hands.
I was gonna say, sit on my hands, I'm sorry.
We can move them to the back and separate them.
Well, I appreciate your help, but it wasn't connected.
That's okay, I'm just teasing.
Well, you forgot the rule we had. If you know the answer, you can only ask questions.
They were asking me, what is this point? What does this drawing mean?
Ask her a question.
Okay, but you can't.
You can't interrupt me to do this.
One person at a time.